Hello everyone, welcome back. And in this video, we're going to talk about arithmetic returns versus geometric return. Now, let's take an example first. Suppose you have you invested for 5 years, then you have the following returns. In the first year, you made 10%. Next year, the second year, you lost 15%, but you have a fairly good investment return on the third year. You made 20%, and then you have 5% return the fourth year, and you'll lose 5% in the fifth year. So, what is your expected return? Well, the question here is like, what does it really mean by expected return? What it really entail? Okay, and so if you start with an initial investment of $100, and what is the value you will get at the end of 5 years? And how does that related to your expected return? Is that expected return what you really think drive the final number there? Now the other question is, if you were to invest that $100 to begin with, and then let's say you made a return, the same return year over year, compounded annually. And if you get to the same number at the end, what is that particular rate that compounds annually you will have? So let's look at an example here. Now, if you look at this table here, so that recreates what we had in the earlier slide. And so you start with $100 here. In the first year, you made 10%, you becomes 110. You lose 15%, you lose 15% based on 110. So you drop yourself down to 93.5. Now you made a very good return. You made 20% here. So 20%, so 1.2 times this thing here, which is 1.112. Sorry, 112.2. Then another the fourth year marginal return, it's only 5%, so your number becomes 117.81. In the last year, you lost 5%, so the value dropped down to 111.92. Now, if you just calculate an average, if you call expected as average, you actually get 3%, okay, over 5 years. And however, if you look at it and say, well, what is the rate that if you receive that return year over year compounded, you will actually get to $111.92. That rate is actually 2.28. Now, this 2.28 is less than 3%. So when people are talking about average return, somehow there's a notion that the average return in people's mind somehow means, something you will be getting on average, like you'll always be getting that return. But really, when you do the actual calculation, the rate that this investment is growing is really only at 2.28%, which is less than what the number, quote unquote, average is. If you look at all the investment brochures and typically people will quote average returns. So give you a whole, from the last 5 years, the last 10 years, what the annual return is, and quote an average. And the reason to call that average is because that is always a higher number. Because the average is a arithmetic average, and that arithmetic average is always higher than the geometric average. And so they may get a sense that you're really getting a high return, but that is really not the return that your investment is growing year over year. So the information that's really relevant is, the whole reason to get specialized with that one number is to get a sense of if my return were to grow at a particular constant rate, what that rate is. And that rate is not average return. That rate is geometric average return, not arithmetic average return. So, and I mentioned that it's always higher where the arithmetic average is always higher than geometric average. So then the question is, in what situation that the two average will be the same? So you can actually see that when there's no volatility, then the two average will be exactly the same. And we can see that from this particular derivation here. So earlier, we have seen that if you look at the, you have a stock price process, and the expected return is actually, well, I should call that the first term, the expected value of the log as t, big T, is mu minus half sigma squared t. So there is a term here that impacts you significantly. So this term is this volatility here, sigma square, half sigma square. So if you have a large volatility here, your you may have large average return. There are some very large positive returns. There are some large negative returns. You may see a number that's pretty big as a arithmetic average, but you're not making that return year over year. The actual rate of return, the constant rate of return that your investment is growing year over year to reach the same number is a much smaller number. The higher the value of sigma, the lower is this particular rate that your investment is growing year over year at a constant pace. What's another place that we can actually see this minus half sigma square impact us? So if you follow the market, you may know there are ETFs that are structured in such a way that bull plus or bear plus, 2 times the return, 3 times the return, or 3 times the negative. They're the ones that is the ETF will be like 3 times the return of the actual stock index, or the reverse one. Well, if the stock index were to decrease, then this ETF will increase, at the 3 times the pace. Now, for those kind of leveraged ETF, this aspect actually becomes very important, because if you just run a time series there, and you look at a just it was large increases, a large decrease, a large increase, and large decreases. If at the end of the day that the stock index actually has gone back to not very far away from where they begin with, and if you look at the value of the 3 times ETF, for example, that value, however, will drop. So if you go then to do some experiment yourself, so if you start with $100, well, mentally, you don't have to try that by actually investing in the ETF, leverage ETF. You can actually do the exercise mentally, or with the help of a spreadsheet. So if you start with $100 there, and you have 3 times the return, you will, if the underlying stock come back to where it is, then your ETF actually, at the end of the day, the high leverage ETF, that value will go below 100. So I'm going to show you an example in the next video. So I will see you next time.